Hello, my name is Michael Sulak, and in this video we're going to be doing some example problems from this book, Algebra and Trigonometry, by this group called OpenStax College. This is a free book. If you Google this information here, you should be able to find the book online. You can download it. We are going to solve this equation. This is an equation because it has an equal sign here. That is a must. If there's no equal sign, it's not an equation and you cannot solve it. So we are going to be solving it, and our variable here is x, and we have everything else is a constant. And so what it means to solve it is we are going to do some work, and eventually we are going to get to a step that we have x by itself on one side and everything else on the other. And if we've done this, then it would be correct to say that we have solved for x. It's important to remember that nothing on the other side of the equation here can actually have x in it. The only x is this one single x by itself, and everything else that's not x is going to be on the other side. So here's our equation, and we have a set of parentheses here. This x plus 3 goes together. When you see a number right beside it, that means that we have to multiply the 8 by both these things. And this process is called distributing the 8. You multiply the 8 times the x, which would give us 8x, and also the 8 times the 3, and that has a plus sign there, so we're going to have a plus. 8 times 3 is 24. That's going to equal 64. And so we're done with that step. Notice that we have rewritten the equal sign and both sides of the equation. Now we're thinking, okay, we want to get the x by itself. So whatever is preventing x from being by itself, we need to move to the other side of the equation. And hopefully you're familiar with order of operations. When you're evaluating expressions or simplifying, you often look to use order of operations with parentheses being the priority over subtraction. But when we are solving an equation, oftentimes we end up working backwards and think about addition and subtraction before thinking about things like multiplication and division. Oftentimes it's just easier to do addition and subtraction before you do multiplication and division when you're solving an equation. So what I mean is, right now we have plus 24. We can just get rid of that with a bit of subtraction. And we're going to subtract 24, and we're going to subtract that from both sides. That's really important. If you don't do that, you are changing the information of the problem. So we have 8x plus 24, but then that's minus 24, which means that the 24's cancel, and we just have 8x on the left side. And then we have our equal sign, don't forget that. And on the right side, we have 64 minus 24. You can do this in your head. If you subtract the 4's first, you end up with 60, and then subtract the 20 and you'll get 40. So now our equation looks like 8x equals 40. Now we don't have any more addition to get rid of. The only thing we have is this 8, and that's being multiplied by the x. So in order to get rid of that, we're going to divide by the same value. We're doing the inverse operation here. The inverse of this multiplication is division. So what happens on the left side is that a lot of times you'd hear that these things cancel out, and they really do. And if you want to know why, it's because you could write that like 8 over 8 times x. That's the exact same thing as what we have over here on the left side. And then 8 over 8 is the same thing as 1 times x. And then when you multiply anything by 1, you're back to where you started. It doesn't change it. So 1 times x is just x. A lot of times you'll hear this as saying, oh, the 8's cancel, which they do. They sort of just disappear. And then we have x equals 40 divided by 8. That is going to be 5. And so x equals 5. And I know this problem was fairly simple. There weren't too many steps, but it's a good habit to check your work. So let's check to see if this is actually the right answer to this equation. So when we check it, we're wondering, does this make the equation true? What we do is we're going to substitute the value of x back into this and make sure the left side equals the right side. So if x is 5, that means we have 8 times 5 plus 3, and that equals 64. And we do parentheses before we do multiplication, so the 8's just going to sit here, and we are going to do what's inside the parentheses, which is 5 plus 3. That gives us 8 times 8. We are wondering, are these actually true? So now we do 8 times 8, and that is in fact 64. So does this make the equation true? Yes. It's probably not realistic that you'll go through and check every algebra problem you do, but especially if it's on an exam and you have time, checking your work is a really good idea, as it could give you an extra 5 or 10 points on an exam easily if you catch a mistake or two that you made. Anyway, this was a video on solving an equation. This is a fairly basic equation, but the ideas here used over and over again. I highly recommend when you're solving an equation to write your work from top to bottom. A lot of people like to work from left to right. Students want to save paper. I do not recommend that. It takes more paper to do top to bottom, but it's just a better idea. Your math homework is not the place for you to try to save the planet.